Right. Hello students, this is Ms. Medina and this is going to be part 2 of the study guide. Okay, so in this part right here it says describe the slope that we see in each of these graphs. So this one is pretty flat going straight across, so we call this one constant, and it has the y value. All right, so if this is y value 3, then it'd be y equals 3. So we say y equals whatever constant it is, okay? This one is a vertical slope. Oh, I guess we can call this one horizontal. And by the way, the slope here is 0. Okay. This vertical line, the slope is, what is that, undefined? Because the denominator ends up being 0. This one is a negative slope. And this one is a positive slope. Yeah, I think all they want is for us to describe the slope. There we go. So, rate of change. Yay, everybody's favorite formula. The rate of change equals y2 minus y1 over x2 minus x1. Rate of change, time, distance. Use the table on the left. What is the rate of change from 0 to 3? All right, so this is x1 and this one is x2. So x1 is mapped to 2 and x equals 3 is mapped to 7. All right, so the two order pairs that we have are 0, 2 and 3, 7. Okay, filling in the formula is going to be 7 minus 2, right, over 3 minus 0. So that's 5 over 3. So, sorry, I was off screen. 7 minus 2, 3 minus 0 is going to give you 5 over 3. That's the rate of change. All right, let's do this from 7 to 10. So x1 is 7 and x2 is 10. Let me grab a different color. So this is the first point, and this is the second one, right? Because 7 is mapped to 18, and 10 is mapped to 8. So we have 7, 18, 10-8. Right? And so for the rate of change, it's going to be the second y minus the first y. It's going to be 8 minus 18. And then 10 minus 7. All right, so it's this negative 8 over 3. So the rate of change is negative 8 over 3. Okay, so this one's a positive slope, and this one's a negative slope. All right, 27. What is the average rate of change of this function from x equals 1 to x equals 3? Right, so we know that the first x is 1, the second x is 3, but we need to find the y's. In order to do that, we have to use the function. So we need to evaluate the function at 1, and we also need to evaluate the function at 3. All right, so that means wherever we see the x, we're going to plug in the value. So this is going to become 1 squared minus 4, which is negative 3. And now 3 squared, right, because it's f of 3, so 3 squared minus 4. And 3 squared is 9, 9 minus 4 is 5. All right, so the two order pairs that we have are 1, negative 3, right? 1, negative 3, and 3, 5. All right, calculating the rate of change. It's going to be the second value minus the first. So 5 minus a negative 3 and 3 minus 1. Okay. Running out of room, so I'll do the best that I can. 5 minus a negative 3 is 8 over 2, so it's going to be 4. So the rate of change is 4. What is the average rate of change of this function from x equals 1 to x equals 2? Well, in order to do that, we'll need to do f of 1 and f of 2. So wherever we see an x, we're going to plug in 1. So it's going to become 1 squared plus 8 times 1. It's going to be 9. Whereas here is going to be 2 squared plus 8 times 2, which is going to be negative 16 minus 4, negative 12. Okay. So thinking about the 2 points, right? The 2 points are 1, 9, and 2, negative 12. Okay. Put a little subtraction ears right here. So it's going to be negative 12 subtract 9 and positive 2 subtract 1. Okay. So I'm just going to write over here negative 12 subtract 9, 2 subtract 1. Negative 21 over 1. All right, so the answer is negative 21. Which has the greatest average rate of change? Use the first and last x values. All right, which means there's more than one function here. So we have a of x, b of x, c of x, and d of x. And so if we're using the first and the last value, that means we're using this and this. So the rate of change is going to be, which ones are the y's? This is the y, and that's a y. So it's going to be 16 minus 1 over 4 minus negative 1. I did the math wrong. I'm sorry. I'm falling asleep. This is 4 minus a negative 1. Did I write it correctly? 16 minus 1 over 4 minus a negative 1. I did. This is 15 over 5, which is 3. So the rate of change for this one is 3. All right, the rate of change for this one, right, is going to be this point and that point. All right, so it's going to be 10 subtract 5, and then 4 subtract negative 1. So that would be 5 over 5, which is equal to 1. Okay, for the next one is 4 and 1, 10, negative 1 and 10. So this rate of change is going to be 110 minus 10 over 4 minus negative 1. Right, so 110 minus 10 is going to give us 100. 4 plus 1 is going to give us 5. 100 divided by 5 is 20. Okay. All right, so this one, to do this rate of change, we're going to need this point and this one. And remember, the y's is the 12 minus the 2. So it's 12 minus the 2, and then the 4 minus the negative 1. 12 minus 2 is 10. 5, and 10 divided by 5 is 2. Whew, after calculating all of those rate of changes, the question is, which one has the greatest average rate of change? All right, so the greatest average rate of change is this one, because it's the highest number. All right, the table below shows partial values of two continuous functions. Based on any interval from the table, which function always has the larger average rate of change? Based on any interval from the table. Okay, so I think with this, we just need to pick two x values. So I'm going to pick 0 for f of x. 0 is mapped to -10, and 3 is mapped to 18. For g of x, 0 is mapped to 4, and 3 is mapped to 11. Okay. So now we just need to calculate rates of change. So this will be 18 minus a -10 over 3 minus 0. 18 plus 10 is 28. 28 divided by 3 is going to be 9 point something. So here we go. 28 divided by 3. 9.3. All right, so now for this rate of change, it's going to be 11 minus 4 over 3 minus 0. 11 minus 4 is what, 7? It is, and divided by 3 is just 7 over 3. Turn into decimal is 2.3. All right, so then I guess this one it is f of x. Okay. Whew, an 80-gallon pool. So we got a pool with water. Of 2 is draining. So water is coming out at a rate of 2 gallons per minute. The number g of gallons remaining is a function of the number m of minutes. What is the domain of the situation? So it looks like input is m, which is minutes, and output is g, which is gallons. So if you put in the time, you get the number of gallons remaining. What is the domain? So the domain is going to deal with the minutes. It's definitely going to start at 0 because time starts at 0. Well, all the choices start with 0. It's going to be this one or that one, clear? Because these are about g and this is about minutes. And no, time can be equal to 0. There's no reason why it cannot, it doesn't have to be equal to 0. Time can be equal to 0 and time can be equal to 40 seconds. So I would go with C.